Hi, it's Becky here, and today we are going to learn about ICU Medical Math. Now, I know medical math can be a little intimidating, but I hope after this presentation you feel a little bit more confident to approach these problems and you find them a little bit easier. So, when it comes to medical math, there's really only two things you need to understand. The first being conversions, and the second being your dilution equation. So C1V1 equals C2V2. So if you understand these two concepts, then you can solve any medical math problem that comes your way. So I like to think of math as a puzzle, and I approach math at a very visual and horizontal manner that I like to call the train track method. So this is my train track down here. I don't know why it's called a train track. It's more of a half of a train track, but for all purposes, we're going to call it a train track. So for our math puzzle, you always want to start with what you know. You're then going to place your units so they cross off accordingly. You want to end with your desired unit. Then, once you have everything in place on your train tracks, you multiply everything on the top of the train track and divide by everything on the bottom of the train track. So we're definitely going to go through lots of examples, so I hope this will make sense in just a little bit. So let's just do a couple simple examples. So we know that 1 kilogram equals 2.2 pounds. So let's say we want to figure out what 40 pounds is in kilograms. So with our puzzle, we start with what we know. We start with 40 pounds. We know that 1 kilogram, equals 2.2 pounds. So we're going to put the 2.2 pounds on the bottom because we want these two units to cross off. So then we have 40 multiplied by 1 divided by 2.2, and those cross off. We're left with kilograms, and that gives us our answer of 18.2 kilograms. Next, we want to figure out what 500 micrograms is in milligrams. So we know that in 1 milligram, there's 1,000 micrograms. So we start with what we know. We have 500 micrograms. We know that there's 1,000 micrograms in a milligram, so we're going to place the 1,000 micrograms on the bottom, so it crosses off with these micrograms up here. That leaves us with 500 multiplied by 1 divided by 1,000. Our units cross off. We're left with milligrams, and that gives us 0.5 milligrams. All right, so last one on this page, we want to figure out what 1% is in mgs per mil. So the conversion for that is 1% equals 1 gram per 100 milliliters. So we're going to start with what we know. So we know that 1% equals this 1 gram over 100 milliliters. We know that there's 1,000 milligrams in a gram, so we're going to place the grams accordingly so they cross off. And you're left with, so we have 1 times 1,000 divided by 100, and we're left with mgs per mil, and that gives us 10 mgs per mil. So remember, you're multiplying everything on the top line and dividing by everything on the bottom line. Okay, so let's get into some more examples. So for all these problems, we're going to be using Rosie the Husky, who weighs 40 pounds, which we just figured out is 18.2 kilograms. We're going to start off with KCl, potassium chloride, which is a very common fluid additive in the ICU. So let's say the doctor tells you to add 20 milliequivalents per liter of KCl to the IV fluids. So we start with what we know. We want 20 milliequivalents per liter. In these questions, you need to know how much fluid you're adding the additive to. So in this first example, we're going to add it to a full liter of fluids, or 1,000 milliliters. So let's start with what we know, 20 milliequivalents per liter. We know there's 1,000 milliliters in a liter, so we need to convert that. So our liters, oops, let me go back a second. Well, we'll come to that. So our liters will cross off. There they are. We know, based on if you look at the bottle, the concentration of potassium chloride, which I have over here, is 2 milliequivalents per mil. So we want the milliequivalents on the bottom here. So it crosses off with the milliequivalents on the top. And then we know that we want to put the KCl in 1,000 milliliters, or 1 liter. So our mils cross off. We're left with mils, and that gives us 10 mils to add to that bag of fluids. Let's say in this problem, there's only 650 mils left in your bag of fluids. So everything starts the same. We start with what we know, 20 milliequivalents per liter, 1,000 mils in 1 liter, 2 milliequivalents per mil, and then instead of 1,000 here, we're going to put 650 mils. So our milliequivalents cross off, our liters cross off, our mils cross off here. We're left with mils, and that gives us 6.5 milliliters. Now, a lot of math is, does your answer make sense? So we know from the first problem that in 1,000 milliliters that we're going to add 10 mils of KCl to equal 20 milliequivalents per liter. So it makes sense that our answer for 650 mils would be less than that. So if I got an answer of, let's say, 50 mils, and I already knew that it only took 10 mils to fill the liter to 20 milliequivalents per liter, that should trigger something in my mind saying, I perhaps typed something into my calculator wrong. This answer doesn't seem correct, and I should redo my problem. So let's do one more. In this example, we have 150 mils in our bag. So everything is the same except for that. So 20 divided by 1,000 divided by 2 multiplied by 150. All of our units cross off, and that gives us 1.5 milliliters. So again, our answer makes sense. So next we have to write our additive sticker. So additive stickers are super important. You need to have as much information as possible so everyone that looks at that sticker knows exactly what you put into that bag. So we have our patient name, we have the date, the time, put your initials, and then we write our drug, the concentration of the drug, how much we put in the bag of that drug, how much we put into that bag, or how much fluids we had to start with. In other examples that we'll come to, it is very important to write the fluid rate. However, in this example, we don't have a fluid rate that we're dealing with. And then we're going to eventually have our concentration or strength of the KCl that we added. So KCl, 2 milliequivalents per mil, 10 mils of that in 1 liter of plasmolite equals 20 milliequivalents per liter. So again, here's just everything you need to have on your additive sticker. The weight and the fluid rate are optional. We'll come again to examples where it is vital to put the fluid rate. So we'll stop there for now and we'll come to some more examples in just a little bit.